Hi guys. So today we're going to look at our number sets, and then we're specifically going to look at the subset of complex and imaginary numbers. So if you look at this chart here, if you look at this circle on the big outside here, those are probably all the number sets that you're pretty familiar with. So the largest circle there is all of the real numbers. And then within that subset, we have smaller and smaller circles. So the smallest circle, those are our natural numbers. Those are the whole positive integers like 1, 7, 300. Then after that circle, the larger subset would be whole numbers, which also includes 0. Then after that, we get to integers, where we also include negatives. And then after that, this larger circle are rational numbers. So rational numbers are any numbers that can be written as a fraction. So like an actual fraction, a decimal that has a fraction equivalent, like 0.99, could be a rational number because that can be written as 99 over 100. Or anything else that can be written as a fraction. Anything that cannot be written as a fraction falls in the category of irrational numbers. And a lot of these are solutions that we're going to see with quadratic equations. So something like the square root of 3 to minus the square root of 5. Other examples of irrational numbers would be like pi and e. And all of these number sets fall under the category of real numbers. And until this point, that's really all we've been working with. Well, now, real numbers actually fall under a bigger subset called complex numbers. And within that subset, there's a section called imaginary numbers. And we're going to get into that today. So to start, there's really two big things we need to understand about complex and imaginary numbers. So an imaginary number, basically I, is the equivalent of the square root of -1. So if I have the square root of a negative anything, basically the negative gets moved to the outside and becomes an I. And that's how we can work with imaginary numbers. Now, if I square I, then I get -1. And those would be the two most important concepts we're going to work with today. Now, complex numbers are basically anything in the form of A plus BI. A is the real part and B is the imaginary part. That's why the entire real number set still fell under complex numbers. It just had nothing on this component. But anything that has an imaginary component, so like 2i, does fall under complex. It's just 0 real plus 2i. But you also can see complex numbers in the form of like 2 plus 3i. So 2 would be the real component, and then 3 would be the imaginary component. All right, so let's look at a couple examples here. Before we get there, though, we're just going to review our operations with irrationals so that we remember some of these rules. So remember, if you have the same square root, then you can add them together. So that would become 4 square roots of 5. If they're not the same root, we cannot add them together. But if we can reduce them and get the same root, then we can. So for example, square root of 8 can simplify to 2 root 2. Square root of 27 would be 3 root 3. Root 12 would be 2 root 3. Then I can combine the ones that are the same together. So 2 root 2 minus root 2 would be 1 root 2. And then this would become plus root 3. And that would be my simplified answer. When it comes to multiplying, any roots, any numbers that you're multiplying within that root would stay under it. So this would become the square root of 6. Any numbers that are outside the root stay outside the root. So this would become 3 root 2. All right, then looking at, again, same idea here. I would go ahead and FOIL this out. The number on the outside would stay on the outside. The numbers on the inside stay on the inside. This would become minus 2 root 5. Then minus 3 root 3, and then this would become plus the square root of 15. Then the last example, we're going to look at something called the conjugate. So in order to rationalize this and then get the square root out of the bottom, I can't just multiply by square root of 2, because that's still going to give me that irrational in the bottom. So what I have to do is multiply by something called the conjugate, which is going to be 1 plus the square root of 2. And if I multiply the bottom, I have to multiply the top. And the reason that we multiply by this is because it creates a difference of squares, which means those middle terms there are just going to cancel out. So when I FOIL this out, all I'll be left with is going to be 1 minus root 2 times root 2, because those middle terms, like we said, would just cancel each other out. Then at the top, I would distribute, so that becomes 3 plus 3 root 2. So I would have negative 1 at the bottom. So that gives me negative 3 minus 3 root 2. So some of the operations that we do with complex numbers are going to be a little bit similar to this, which is why we wanted to review these. All right, so dealing with imaginary numbers. Again, anytime that there's a negative inside the square root, we basically make that an I outside the square root. And then the square root of 25 is 5, well, really plus or minus 5, I. So same thing here, this is I times the square root of 20. Simplify the square root of 20, and this becomes 2I root 5. Now with notation, sometimes you're going to see that I in that position right there. The reason we like to put the I there is just because if I didn't and instead I said 2 root 5I, which is perfectly okay. The reason we just don't like to do this is sometimes it's hard to tell whether or not that I is under the square root or not. So if we put the I in the in-between, it makes it really clear that the I is being multiplied and it's not actually under the root. All right, so the square root of negative 72, that would be 6I root 2 plus or minus. Square root of negative 11 would just be I times the square root of 11. So now we're going to look at I raised to certain powers. So this I squared is a really important one. I squared is going to be negative 1, and that one's going to be really important for us to know. Because basically all of the rest of these are going to be derived from that fact. So I cubed is the same thing as I squared times I. Well, I squared we just said is negative 1, so that means that I cubed would just be negative 1 times I, or negative I. I to the 4th, I squared times I squared, which would be negative 1 times negative 1, which is positive 1. So now every other exponent basically is going to be some form of this. So for example, I to the 16th, well, that's the same thing as I to the 4th to the 4th. Well, I to the 4th is 1. 1 to the 4th is still 1. Something like I to the 23rd, what we want to do, if I to the 16th is 1, well, any basically multiple of 4 here is going to give us 1. So what we want to do is we want to look for the closest multiple of 4 without going over. So in this case, that's I to the 20th. Well, that makes this the same thing as I to the 20th times I to the 3rd, which means that this is 1 times I to the 3rd. And I to the 3rd, we know, is negative I. So I to the 23rd is just negative I. All right, I to the 82nd. Again, we're going to look for the closest multiple of 4. That would be I to the 80th. Well, that is just 1. So we're left with I squared. I squared is just negative 1. So that's how we simplify those values of I. So something else that we're going to look at is just how to graph these. Now, when we graph them, they're very simple, but we're graphing these on an entirely different coordinate plane. So the way this works with graphing, what looks like our x-axis is going to be the real component, and then our vertical axis is going to be the imaginary component. So 2 plus 3i, basically this is going to be our over 2, because it's real. That's the real part. And then the imaginary component is 3, so then I would go up to 3, and that's where I would plot that point. So negative 3 minus 3i has a real component of negative 3, imaginary component of negative 3, so there's my point. 3i is just going to be right up here because it doesn't have that real component, it's just that imaginary component. So something else we can consider, and it helps a little bit when we graph it, is if we look at absolute value. So absolute value here, it's still the distance away from 0, but we don't say just from a 0 in a certain axis. We're actually saying the distance from 0 as in the origin. Okay, so the distance that point is from the origin. So for 3i, well, the distance that point is from the origin, that's a distance of 3. 2 plus 3i, if I want to look at the distance 2 plus 3i is from the origin, then I would draw basically that purple line right there. I'm looking for that distance. Well, the easiest way to find that distance, I know this is 2, and I know this is 3. Well, now I have a right triangle, so I'm just doing Pythagorean theorem. Pythagorean theorem is just 2 squared plus 3 squared, and the square root of that is the square root of 13. This is pretty similar, I think, to what you guys did with magnitude, probably, if you were doing vectors in physics. All right, so negative 3 minus 3i. Again, if I want to find that magnitude, that absolute value, I'm looking for that distance. Well, this is 3, this is 3, so it's the square root of negative 3 squared plus negative 3 squared, which is going to be the square root of 18, which is 3 root 2. Another way to do this one that might be a little bit simpler, if both of these are 3, well, then that has to be a 45, 45, 90 triangle, and your 45, 45, 90 triangles are x, x, x root 2. All right, so now we're going to look at some operations. So when it comes to addition and subtraction, it's very simple. You're basically just combining like terms. We're going to keep the real parts together. We're going to keep the imaginary parts together. So 2 plus 3i plus 4 minus 2i would just become 6 plus I. With subtraction, just be careful again. Everything that follows that minus is going to be subtracted. So this is going to be... All right, sorry guys, you're getting all the distractions today on the video. All right, so again, when we subtract, we make sure we subtract everything that follows. So this is negative 2 minus 3. This is 5i minus negative 2i, which is 5i plus 2i. So whenever we multiply, we're still going to FOIL. What we need to keep in mind here, though, is anytime we have I squared, that's going to become negative 1. So now when I FOIL this out, that gives me minus 3i plus 3i plus I squared. Those cancel out. And remember, I squared is negative 1, so negative 9 minus 1 is negative 10. All right, C, my D on B, we'll go ahead and FOIL it out. So that's 9 plus 12i minus 12i minus 16i squared. Minus 16i squared just becomes plus 16. So this is 25. Now, these won't always work out to just be a real number. This just happens because of the opposite signs here. So let's look at another example. Again, FOIL it out. So 6 plus 2i minus 15i minus 5i squared. So I can combine those like terms together. Minus 5i squared is the same thing as plus 5. So this becomes 11 minus 13i. And then this is writing this answer in standard form, where this is the real part, this is the imaginary part. Now on F, what we need to make sure we do here, before you multiply this out, we need to write, so before I multiply this, I need to write this as an imaginary number. So I'm going to rewrite this as 2 plus I root 2, and then 3 minus I root 3. Now I can go ahead and multiply and FOIL this out. So I would get 6, then I would get minus 2i root 3, then I would have plus 3i root 2, and then I would have minus I squared root 6. Well, minus I squared root 6 becomes plus root 6. And then I cannot combine those other two together because they don't have the same root. Now, again, because I told you guys it's all right to leave that I there so that we make sure it's clear that that I is not under the square root, it'd be okay if you left your answer there, but I want to rewrite this a different way so that it looks like that standard form, just because if you were to see some multiple choice options down the road, you probably wouldn't see it formatted this way. What you'd probably see instead, you'd still have 6 plus root 6, but then you'd probably see this written as 3 root 2 minus 2 root 3 I. And that really puts it in that A plus BI form. Now again, it's okay if you leave it in that form in here, but it's just good to know that those two things are equivalent. It's just a different way of writing that answer. All right, so the last thing we're going to look at, we don't really do division, but we do need to rationalize very similar to how we did with square roots. So in order to rationalize, just like we did with square roots, we're going to multiply by the conjugate. So the complex conjugate, instead of 3 minus 4i, we're going to multiply top and bottom by 3 plus 4i. And then I would just distribute on the top. So that's 30 plus 40i over 9 minus 16i squared, because remember those middles will cancel out. So really that gives me 30 plus 40i over 25. And then I can separate this into the real part and the imaginary part. And then I can reduce those. And I have my answer in standard form. B is a really good example of why we usually write the I over here. Because again, it's kind of hard to tell. That I is not under the square root. Okay, that I is not under the square root. So to get rid of that, I would multiply by 2 minus root 3i, top and bottom. So on the top, that would give me 6 minus 3 root 3 times I. On the bottom, that would be 4 minus 3i squared. Again, those middles will cancel. 4 minus 3i squared is just 7. So now I can split this. This is 6 over 7 minus 3 root 3 over 7i, and it's in that a plus bi form. All right, looking at C, again, multiply by the conjugate, which is 2 minus I. So on the bottom, that would be 4 minus I squared. On the top, that would be 6 minus 2I minus 3I plus I squared. So then if I reduce the top, that would become 6 plus I squared would be 6 minus 1. And then on the bottom, 4 minus I squared is 4 plus 1. So this becomes 1 minus I. All right, then in D, technically the conjugate here is negative 3i, but if you multiply by positive 3i, you would still end up with an answer. It should end up as the same answer when you completely simplify it as well. But let's go ahead and just multiply by negative 3i, so top and bottom, so that would give me negative 9i plus 3i squared, and then negative 9i squared on the bottom. So that gives me negative 9i minus 3 over positive 9, which would then reduce to negative 1/3 minus I. All right, so that's it for complex numbers. So just remember the square root of a negative, you basically just take the negative, move it to the outside, make it an I. And then the other big thing to remember is that I squared is going to give us a -1.